The website, svec.org. Our keynote speaker today is Dr. Val Nitaka. He's the founder of Electric Motor Works, a California group focused on promoting high-performance electric conversions. He started EMW to help dramatically accelerate adoption of electric car conversions and raise the image of the affordable electric car solutions. Over the past 10 years, Val has held a number of executive business strategy positions in various high-tech and management consulting companies, including Google, Nielsen, and McKinsey & Company. Val received his PhD in physics from Princeton University and his MS in physics from Moscow Institute of Physics and Technology. He is a two-time winner of the National Russian Physics Competition. Let's welcome Dr. Val Nitaka.
Works. Hi everybody, thank you for having me. Appreciate your time. Looks like a very interesting group. Thank you Laura and Michael and good for having me. So to kind of continue the tradition of asking a question in the beginning of the presentation, how many of you are driving electric cars today? 1, 2. All right, good count. Okay, the next question. How many of you drive hybrids? About 10 people. How many of you were driving hybrids 5 years ago? 1, 2. Okay, so hybrid graduated to electric. That's great. Yes. Okay, so you can see the trajectory, but also you can see that electric transportation is not quite a mass choice today. And what I'm going to talk about is why it will become the mass choice in the next 10, 15 years, and what our company is doing for that. But first, some history on electric cars. So everything started over almost 200 years ago as the electric cars were invented. And actually, for a long, long period of time, the electric transportation, or electric cars, were the dominant type of the personal transportation. And in the United States in 1912, electric cars were the most successful type of the personal transportation with a peak of production. But what happened then? Cheap oil. And as a result of that, a lot of great, non-polluting, quiet electric cars were slowly substituted by noisy, polluting, and dangerous at that time gasoline vehicles. But they were cheap. Henry Ford revolutionized the automotive industry by offering $600 was the first pricing of the first model. And compared to electric cars that were mostly luxury items as about 1/3 of the cost. So everybody just went for that. And then what happened is, over the next 80, 90 years, reign of the internal combustion technology. But it did came at some cost. So you probably all know all these reasons, but some of the numbers were actually, as we were doing some of the research for this a while ago, some of the numbers were pretty surprising. 50% of U.S. oil goes for transportation. Over 30% of U.S. CO2 emissions are from transportation. It actually takes about 1.5 acres of fully grown pine trees to offset the emissions of just one car, driven on average 12 to 15,000 miles a year. And 50% of oil consumed in the US, maybe this is a number from 6 months ago or so, is imported. And none of these things are good for us, right? We talked about global warming, we talked about the foreign oil dependency, funding questionable regimes around the world because of that. And one thing that is actually, for this group is probably pretty obvious, but for most people is not, that oil is a very strategic type of resource that using it for transportation is actually quite a bit of a waste, given how many products oil is used for. Everything from the medicine to everyday clothing items to plastics. A lot of the products have oil as their basis. And we're putting that kind of supply under pressure by using more and more of it in transportation. So for those reasons and for some others, electric cars are back, not in huge volumes yet, but starting with Tesla, founded in 2003, with the flagship electric roadster, which could do, I believe the latest model was 3.4 seconds, 0 to 60. Pretty fast car. Costs only $100,000 or 120, latest price, but still faster than $300,000 Ferrari. And a bunch of followers came, including Nissan Leaf and Chevy Volt being the largest volume sellers, at least at this point. And some of the more glamorous manufacturers like Rolls-Royce and Porsche came in to the party as well. So we see a little bit of resurrection of the electric car, and Chris Payne, who's one of my friends and also director of a couple of movies about this, Who Killed the Electric Car and Revenge of the Electric Car. I don't know if you guys have seen it, those movies, but he described the whole process pretty well. And if you haven't seen those movies, I highly recommend to take a look. The culmination of this, actually, a week ago or maybe 10 days ago, Tesla was, and I see a Tesla engineer there, right? Pounding fist in the air, it's great. 10 days ago or so, Tesla was awarded the prestigious Car of the Year award by Motor Trend magazine, which was the first occurrence in 64 years of that magazine's existence, when the award was given to a car that is not propelled by internal combustion. So that was a big deal, right? And when they were asked, from multiple sources, they were asked a question why they did that, and whether this had anything to do with the car being electric and new technology and everything. And basically the answer they gave is it's a damn good car, and it just happens to be electric. So Tesla is at least one of the manufacturers, one manufacturer who figured out how to build a car that's the best car in its class, and it just happens to be electric. So no more compromises. So what's ahead for electric cars? These two charts actually can say by themselves. So the top one is the gas price, and you guys probably all feel that in California, that upward curve. Actually, it's closer to this point now. It's around 4 points something in California. And this is a lithium battery technology price trajectory on a cost per kilowatt hour. My friends from McKinsey have just completed, in July, I believe, they completed the latest study on the transportation. And they came out with a few projections, including saying that by 2020, the price will go down to $200 per kilowatt hour. And actually, Tesla and some of the semi-confirmed claims claim that they already have almost $200 per kilowatt hour price in their batteries. And it will go down even further. And if you try to do some economic analysis around this and try to put together some numbers, you see that in 5 years from now, just like I said here, we will actually have economic parity of the electric drive for mass transportation if you consider the typical lease duration. So in 3 years, you would be able to recoup the cost of the battery just from less money spent on gas. So that's pretty remarkable. And you can imagine how companies, like large companies, could take advantage of that by just loading your lease payments, effectively, right? So they could amortize it for you. Everybody already buys cars for 3 years. That's the typical lease duration. And after that, the battery is fully amortized and there is no more cost involved. So that's really good news, right? So in 5-7 years, we should expect at least the reasonably short range, medium range electric cars to go into the mass. And yes?
So I love your numbers. It's just that since this is the Silicon Valley Engineering Council, and
Yep.
there's some mechanical people around, if the Detroit people say, yeah, it's the right graph and it's ultimately eventually the right truth, but it's not 5 to 7 years. You need a $2,500 30 kilowatt hour battery, not a $7,500. So could you go into a little bit of detail about why you chose 7,500 instead of 2,500?
Yeah, sure. So basically, if you just plug in the numbers in terms of the gas cost and the average mileage that the passenger vehicle would get, which we took as 30, right? And consider the relative cost of electricity versus gasoline, you will end up saying something around $2,000 to $2,500 per year saved in terms of the just gas price, gas cost alone, fuel cost alone, by driving electric. In addition to that, lower maintenance fees, because you don't have oil changes and all the breakages add to that number. So you have about $2,500 a year in terms of the savings. And then over the 3-year period of the car lease that is typical in the United States, that ends up being $7,500. So that's where we got it from, right? So during the typical ownership period in the United States of a car, you will be able to amortize your battery through just savings on gas. Yes?
Does that include parity on the vehicle tax basis, or is that on current market basis?
It would be on a current market basis, right? So this does not imply any kind of tax benefits, right? Because 5-7 years from now, we're not going to have tax benefits.
If electric vehicles take off and they actually start taxing those, what percentage of your advantage?
Oh, you mean taking the gasoline tax, for example, and applying it only? Yeah, well, that's a good point. So that probably adds one more year to this trajectory. It's a good point.
Aren't gas about 50 cents a gallon?
Yeah, so they're
So
not.
it's only 10%.
They're not super dramatic, right? So that's why I'm saying, you know, it's just maybe 1 year addition, right? So instead of 5.7, we're talking 6.8, right? But the trajectory is clearly there, and there is no kind of going around it. The materials are relatively accessible for electric vehicles, especially if you talk about non-rare earth metal motors and lithium batteries. The materials are pretty accessible. So there are no shortages of the minerals, like oil, for example, in order to power the cars. So the question that, and we're transitioning to what we do at Electric Motor Works. The question that we asked ourselves about a couple of years ago is, can we help that transition to become faster, right? And you rightly mentioned there are a couple of challenges with electric cars today. They're too expensive. We still don't have a lot of choice in electric transportation. There are only a few models out there compared to hundreds of models of the regular cars. The replacement cycle of the average car in the United States is still 10 to 11 years, which means that even if we start selling a lot of new cars as electric right now, it will take 10, 15 years to replace any significant portion of the fleet, right? So, and then the last one is just for some of the high performance cars, the core car technology is still unproven. How does it interact with the electric drivetrain and things like that? We still don't have full field testing on that. So what we are trying to do is to offer a different proposition. We take the existing high performance, high quality vehicle platform, like a BMW or Audi or Mercedes. These are actually our first 3 target platforms. And we make it electric. We convert those cars to electric. And we focus on the current generation and the previous generation of cars, so you can say, hey, here's my 3-year-old car, and I want it to become electric. And actually, if you run the math, it is today, the cost of conversion is about 40% of the new electric car cost. And through some of the existing incentives, you can actually reduce it to about $10,000 per car, which puts it into a pretty accessible territory. And also, if you can figure out any way to capitalize it over time or amortize it over time, it becomes very attractive. So that's sort of where we are. So we just said, hey, in 7 years, we'll see $7,500 battery. So what we are saying is, right now, it's a $10,000 investment, right? Which brings it closer to the reality by a few years. So that's what we're trying to do, in a nutshell. And like it says here, there is no penalty in performance that we see. So we take a BMW. If it's a previous generation, like an E46 BMW 3 Series, we will make it faster. We actually have better acceleration numbers, better tops, to some extent, better top speed numbers than the original car, unless it's an M edition. We can't make that faster yet, but one of our cars is actually outside, so once the event is over, you can take a look at the prototype, one of the prototypes that we have. Here's some picture. I already talked about it, right? Tesla wishes best car that exists right now, apparently, in that price range, according to Motor Trend, so that's pretty good. But it's still a $60,000 car, $50,000 after rebate. By any kind of stretch of estimation, probably $500 million cost in terms of the R&D investment. And a full regulatory burden as a new car, right? So you have to certify, go through all the certification process, because it's a new chassis and new everything. So our proposition here is the price tag is quite a bit less. And as I mentioned, if you talk about applying similar rebates and also some of the parts resale, which we can do at scale, you're talking about just $10,000 investment. The R&D cost is quite a bit lower on a per make basis because you don't have to re-engineer your car. You already have a pretty good platform to start with. And the regulatory burden is actually lower because you already have a certified frame and you don't make any adjustments to it. Everything is plug and play. You don't change the weight, total weight. You don't change the weight distribution. And a lot of the regulatory burden does not apply anymore. So that's a pretty good proposition. And on top of that, our applicable base is 250 million cars just in the US, registered just in the US. For comparison, we had about 20,000 electrics sold, maybe this is an overestimation, in 2011 and 25K to date in 2012. Right? So there's quite a bit of difference, and that speaks to the, if we can figure out a way to leverage the existing installed base, we can really move this thing. All right, I'm going to skip over some of the stuff.
Sorry, you got a question in the back here.
Yes.
I understand that the California state gives the HOV sticker to only new electric cars, so new hybrid cars. So would the sticker be available for the converted car?
Yes. Yes. We actually, so the prototype that's out there is registered with the DMV as an electric car. And it is eligible for an HOV sticker as a zero emission car. Right. So there is no, and there are a lot of people who, actually the conversion industry, up to now, it was pretty much a boutique industry, right? So there are some conversion shops around the country that can take your car in, and they will take a few months, hopefully weeks, to convert it with a homegrown solution. And a lot of those cars are driving around with HEV stickers too. It's just, on an individual basis, it's a bit of a cumbersome process to go through all the hurdles. But once you kind of figure it out, this is just a process to go through for our customers. Oh, okay. Just some eye candy for you guys, being the engineering society. So this is the front of the vehicle that we're talking about. This is a 3 Series example. So we basically have to work. The problem with conversions, right? If you have to work with the space that you already have. You don't have the luxury of being a Tesla mechanical engineer and saying, hey, I'm going to put a battery on the bottom of the vehicle and this is going to be great, right? And you can use all the space to just for cargo, for people space. So we don't have that luxury. But what we can do, what we've developed, is a solution that gives us 100-mile range or more without taking up any space, any usable space in the car. So your trunk space is all preserved, and your passenger space is all preserved. Even BMW couldn't figure that out. When they did their 1 Series conversion, which is the Active E, they actually took half of the space in the trunk for components. So this is the front of the vehicle. It's about 2/3 of the battery pack, the motor, the controller, and a couple of other components that they fit in. And there are a total of 5 battery packs around the car that actually result in the 50/50 weight distribution, or preserving weight distribution, that EMW is so proud of. So the handling is preserved as well. Company, we have a number of patent applications that are patents in various areas. I'm happy to talk to you guys about them if you feel like it after the event. Some technology I'm just going to skip through, given how I'm doing on time. So our strategy is, in terms of the plans, is to provide our solutions to the franchised network of locations that would that would perform the conversions. We would also have our own centers, roughly 1:10 ratio to the franchise locations in high traffic metropolitan areas. We already have a pretty good interest from a number of potential partners who are in the first phase. Include people like existing converters who are used to operate on a every car is a custom solution, so they really like the idea of plug and play, bolt-on type of kits. And also we got pretty good interest from the tuners, the regular car tuners who are working on cars and souping up these vehicles all the time. Okay, as I mentioned, we have a few prototypes right now running on the roads here, registered cars. We are working on the SUV conversion, also the EMW X5 conversion. So we have 3 Series, and we're expanding it into X5 as well. And we plan to start limited installations sometime, hopefully early next year. We already have about maybe over 100 customers for our components, various types of charging systems, instrumentation, and so forth, and a few trial customers for the kits. And we plan to ramp it up next year, hopefully early next year. Just some pictures here. This is the first car we ever did. It was an old Fiat, and a lot of manual work on it. That was 2 years ago. This is us at Makers Fair. All right, so thank you very much. And just a little plug here. If you're power electronics, industrial design, or transportation regulatory, we want to hear from you.
Yeah, question.
Yes.
What would you, let's say for students in college and they are interested in electric cars as their career, what do you suggest them, what areas of concentration and things they should work on
Right.
while they're still in school?
So mechanical engineers or electrical engineers?
Well, both.
Yeah. Well, so given, and I'm probably biased, right? But given what I know about the market trajectory, I think that there is a bright future definitely in electric transportation, and it just doesn't include just, or doesn't limit, is not limited to just personal cars, just personal transportation. Actually, a lot of the new research and new activity, business activity is happening in the heavy transportation. Electric buses, electric hybrid trucks, and things like that. Actually, there's several good companies that are doing some things there. So the point is that that field will definitely grow. So if you're an electrical engineer, I would highly consider to look into power electronics and maybe get an internship or two at a company that has an electric vehicle program. That would be great. We are actually ourselves are interested in such people as well. So you know, if you're available and are interested, we want to hear from you.
And then for mechanical engineering students?
For mechanical, it's a bit less specialized, right? Because mechanical engineering in an electric car, to a large extent, is similar to the typical car, with the exception of the drivetrain components, which you know, our Tesla friends can attest to the difficulties of developing the transmissions and gearboxes for high power electric cars, right? There is a lot of mechanical engineering new approaches that are involved there. So maybe in that area. Yes.
Can you make your slide set available to us?
Yes. Yeah.
In your card?
Sure. Sure. Yes. Yes. Back there.
Any chance you could get BMW to sell you cars without engines and
We asked that. We were told that once we are at 1,000 or more units a year, come to us.
and how much would that save in cost?
Depending on the model, but about a rough estimate is about 10,000. Yes.
Your conversion rate, what is the percentage of components which are imported? Do you use imported components or they are all made in USA?
Not all of them. Pretty much, with recent events in battery space, there are no more battery manufacturers that build batteries in the United States. So our batteries are imported from China. And pretty much everything else is domestic manufacture.
So what is the ratio of the domestic?
Well, in terms of the component cost, about 50-50. Yeah. Yes.
How big's your battery pack? How many kilowatt hours?
For 100 mile, it's about 33 kilowatt hours. Yes.
Every time I talk to someone about electric cars, I always bring up the electric grid. Can you give me some comments on where you think we're going to go with our current electric grid so we can support true, electric car growth?
Yeah. Yeah. Actually, that's a good question. I actually had a slide on this in the previous version of the deck, and I took it out. I figured, it's not quite electric car specific, but it talks about the typical electric consumption and distribution volumes by time of year or time of day. And if you look at it, right, there is a clear peak during the daytimes, right, and there is a trough in the during the night times. And if you do the analysis of, hey, if you have the electric cars recharging at the off-peak times, you can actually convert up to 50%. With smart grid, you can convert up to 50 to 70% off the cars without needing extra capacity, extra generation capacity. Your plants are just, some of the plants cannot even stop, right, unless you need to stop them for several days, like nuclear or coal-fired plants. And a lot of capacity is just sitting there on the peaker plants that are working only during peak hours, right? So if you have smart grid, which can tell the car, hey, charge now, you can do 50-70% of the current flip. If you don't have smart grid, you can still do up to 20% without any adverse effect on the grid, which is a pretty high number if you think about 250 million cars in the United States, right? So you can do 50 million cars without retrofitting the grid, just by taking advantage of the fact that most people don't drive during the day.
You're saying 50 million cars that you run the grid without?
Yes.
Your slide showed what, 15 kilowatt charging unit.
Right.
That's about 120 amperes. At 110 volts.
Well, it would be out of 240 volts. So about, 70, 70,
60, 70, yes.
70.
What kind of facilities do you envision? 5, 10, 20 charging stations at some location?
Well, we're using the same charging stations as everybody else, right? So the level 2s are 7.2 kilowatts, or about 7 kilowatts. So our chargers are just getting automatically derated when they're plugged into that. 15 kilowatt we get in at home location. Right? So for the customer, we would wire the house, similar to what Tesla does, right? With the 20 kilowatt charging systems and all that. So we would help the owner wire the house for 15 kilowatt charging. So this is about 2-hour recharge off 100-mile car. Yes.
So those of us who watch Jay Leno's Garage know that Jay Leno is a great fan of electric cars, but he'll also tell you that batteries don't do so well at low temperatures. So I was wondering, what your national rollout plan looks like when you factor in temperature lifetime for batteries.
Yeah, it definitely takes that into account. So there are two parts of the story. One is, yeah, you're absolutely right? It's a chemical reaction, and it's not as fast as in the cold temperature as in the warm temperature. So we are following the lead of Nissan Leaf and everybody else who started the introduction in the warmer climates. So that's one side. But the second side is our supplier, our battery supplier, actually earlier this year, they came out with the new battery, updated battery technology. It's the same chemistry, same everything. They just added some additives to that, which can work. Used to work only until -20 centigrade. Sorry about the centigrades. I'm Russian. They're Chinese. So and now it's now they go down to -40, which is pretty much everywhere in the United States where you would characterize anyway. So we will start in the warm climates, and by the time we're in cold, which is 2 years from now, that technology will be fully cooked.
So you'll have 100-mile range at -40°C.
If you don't push it too hard. No, but what I mean by that is when you put, even in the warmer climate, right? If you push the car, which electric car guys can tell you, if you accelerate, 0 to 60 in 5 seconds and go 100 miles an hour, you're not going to get 100 miles, right? You're not going to get 300 miles out of your gasoline car doing that either, right? So it's sort of basic energy efficiency thing, right? Applicable to all types of cars. So our 100-mile range is actually a freeway range. So 65 miles an hour, if you go on the freeway at 65 miles an hour, you get 100 miles, right? If you start and stop all the time, and if you accelerate from the stop to beat everybody else, then yeah, you're not gonna get 100 miles.
So it really is the car for 80% of Americans and 80% of the country.
Yeah, which is
Okay.
good enough. Good enough for us.
Yeah, you can buy that.
For now. Yes. What kind of motor? So right now we actually we used to have our prototypes on the DC motors, and now we're working on getting the brushless permanent magnet motor, which still has the rare earth metal problem. So we'll be looking into that as well. It's a lithium iron phosphate. Yeah. Yes, back there. Yes.
Talked about providing the solution for 80% of Americans. So, would you also, you talked about EMW conversion kit. Do you have a conversion kit for a Snapdragon S1 1991?
That's a great question. I actually know a few people who run conversion shops that would do that in maybe 2-3 months. So we don't. The answer is we don't. When we try to figure out what part of the market to focus on, we did quite extensive analysis of, hey, what's the psychological profile of different owners of different brands and makes, and also looked at the sort of economographic profiles, and we ended up with BMW as our starting point, and overall mid-market cars, which are BMW, Mercedes, and Audi. These are the top three brands. So we'll start with those, and then we'll expand from there. I don't know. I'm doing time. Probably not good. So one more question. Okay.
Is Volvo going to be on that list?
We'll be 3 years from now.
That's about right.
All right. Thank you very much.